About you being up like that?
I just like being comfortable.
Oh, well, thank you. I'm just used to some of them being up all the time, so got over it.
And then, did you see my grade about, or my email about? I guess it's an email about Khan Academy. It was like number 25.
I put it in.
Okay,
yes.
thank you.
On some of those, you're definitely. I'm not sure if it should have been late credit, so I gave you full credit.
Okay.
I know you're definitely flirting with late credit.
Cool. All right.
Like if you're out sick and you can't do anything, it's one thing, but if it's school business and it's a planned absence, you should be not too far behind us.
Cool. Thank you.
Yep.
So I was absent on Monday, so I didn't write a test, and I signed up today for prime time. Will I take it today?
Yes. Yeah, in prime time. I don't want you to fall behind on this stuff, so I don't have you do it during class. morning, guys. There was a handout this morning.
Good morning, FHS. Today is Wednesday, September 20th, 2023. Please join me in a minute of silence. Please stand if you are able and join me in the pledge. I pledge allegiance to the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day.
All right, so we are now starting our second unit since we had our test last time. If you missed last class, make sure you have a plan about making that up if you haven't talked to me yet. So we move right back into section 4.4. Just to give a quick overview of what our second unit is going to look like. 4.4 is very, very, very similar to the stuff we've been doing in 4.1 through 4.3. This is where, if you've been keeping up with what you need to do and doing your best, this section should be quite a bit easier. But of course, the flip side is that means we don't spend as much time there. This one in particular, we will quiz over next class. Well, it'll be the second half of class though, so the stuff that we're about to go over in a minute. And then section 4.5, we'll talk about graphing sine and cosine graphs. We go really in depth with that, and that is really good for the ACT because it's one of the things they ask almost every single time now. And then finally, 4.6, we learn some other trig graphs. So most of Unit 2 is about graphing, but 4.4 is really more or less a continuation of stuff we have been talking about. So our plan today is we're going to talk about our notes here, work through the assignment as much as we have time for. What we don't get to, you'll need to do for homework. And then next time I see you guys know I normally don't take questions on quiz day, but there are some exceptions to that, and that would be this. So next time I see you, the first 45 minutes of class will be time to ask questions and study. In the second half of class, we will quiz on this. So, again, most of this is stuff that I think you would guess, but there are a few terms and a few question types that we haven't seen. So really, what we are now doing is trig functions of any angle. So, also angles that land in the second, third, or fourth quadrant, which we've done a little bit. So, sometimes a point's given to you, sometimes a picture is given to you, but either way, you need to start off with a picture. So, plot -8, -7, and the directions tell us that this is a point on the terminal side of our angle. So terminal side is the side that moves as opposed to the initial side that stays on the positive x-axis. So far all I've done is plot a point. Now really the only thing new about this question is what I'm about to do in the next 5 seconds. We are going to take this point and draw it to the x-axis to make a right triangle, never to the y-axis. And now it's like I have two lengths of this triangle. If I'm going left 8 and down 7 to get to this point, we can think of this length as -8 and this length as -7. we could do Pythagorean theorem to find the third side. And that's 113. So that's not new. And then the angle that we're going to look from is this angle here by the origin. So now we can give off sine, cosine, tangent, and all of the reciprocals. So now that we've got our triangle drawn for us, opposite over hypotenuse, you still have to rationalize. Cosine is adjacent over hypotenuse, needs to be rationalized. Tangent is opposite over adjacent. We can reduce. Can flip these if you wanted to, but then you'd have to rationalize again. So cosecant, I might do hypotenuse over opposite, and secant, I might do adjacent, or hypotenuse over adjacent. There's our answers. So going from sine, cosine, tangent to secant, cosecant, cotangent, you guys have been doing that for weeks now. Hopefully that shouldn't be a major struggle for everybody. It might be something you need to practice more. Hello. It is. No, I can't do. I don't have time. I don't. I'm teaching them something they're quizzing on next class. So, thanks. Okay. So to go from sine, cosine, tangent to secant, cosecant, cotangent, we're familiar with that. We should be familiar with how I came up with these with SOHCAHTOA. Really the only new thing, I'm going to go back and highlight it, is I plotted this point, and from this point I made a triangle. So practicing that a couple times, you should feel pretty good with these question types. But one more time, let's say the point was 4, -6. Again, sometimes this is plotted for you. I think the first two book questions, other than the vocab check, plot it for you. This is the terminal side of the angle. So remember, terminal is the side that moves as opposed to the initial side that stays on the positive x-axis. And then really the only three things. You have to know to make a picture. You have to plot your point. We haven't plotted points together, but obviously you can do that. And then you have to take this point and draw it to the x-axis, not to the y-axis, never to the y-axis, always to the x-axis. And the fact to get to this point, you have to go right 4 and down 6 is like you have two side lengths of your triangle. Everything after that, well, okay, I guess you need to know which angle you're looking from. You're looking at this angle that's by the origin. But now we could do Pythagorean theorem. That would be square root of 60, which is 230, 215, which is 2 square root of 15. And then we can do SOHCAHTOA for sine. Cosine and tangent. Of course, you still need to rationalize and reduce. So I'm not.
Yeah, that's what I was.
24? Oh, right here. Thank you. Yeah. So I guess the mistake for mine you want to learn from is don't coast too much. Just because I got to the point that I was feeling kind of comfortable, I shouldn't have tuned out here. So this would be 52. Square root of 52 would be 2 and 26, which is 2 and 13. So this would be 2 square roots of 13. So That's actually a pretty easy fix. Makes that 13 and this 13. Makes that 13, so this would be 13 and this would be 13. Thank you for catching that. And of course, if you have sine, cosine, tangent, you can flip your answer over for cosecant. Now, just so you guys know, sometimes it's smarter to flip back here. If this is equal to this is the answer I'm expecting for sine. You have to rationalize. But back here, I can see how this reduced, and I just did that in my head earlier in this step. Again, I'm not really focused on this step because you guys have been doing this, and you'll get to practice this more in the bookwork. But it probably makes sense to flip back here than it does to flip here. Because if you flip this, you still have to rationalize and then resimplify. Same thing with secant. You could flip this over, but then you're going to have to rationalize and simplify. Or you could just flip this over. Also, I reduced that in my head. So flip that over would look like this, and then cotangent, flip this over. So reciprocal functions are the same. Sine, cosine, and tangent are still coming from SOHCAHTOA. The only difference is we're plotting a point to make a triangle. That triangle has 2 of 3 lengths. Okay. Any questions about the first couple steps of how I got started on there? Okay. Then something else that's going to come up in this one is we now expect you to be able to tell us which trig functions are positive and negative in each quadrant. So the long way to do this, and I'll show you a short way. So we didn't put anything like this on your test last class, but we could have. Because you know the unit circle and you know these points, all of the cosine values are x. So cosine's positive in quadrant 1. Y is all the sine values, and they're positive in there, so that means sine is positive also. Tangent is sine divided by cosine, so a positive divided by a positive will be positive. And then reciprocals, well, flipping a fraction has nothing to do with changing its sign. If a fraction's positive, you flip it over, it's still positive. If a fraction's positive, you flip it over, it's still positive. So everything's positive in quadrant 1. Just thinking about what we know from the unit circle, we can see that sine and cosine are positive. We can solve for tangent, which we see as positive, and if all of those are positive and you flip them over, they're still going to be positive. Okay, in quadrant 2, some of this stuff still is positive, so now I'm only going to write the stuff that's negative. Now I'm going left, so all of these points we memorize on the unit circle, they have a negative x value, so that means cosine is negative, and his reciprocal would be negative. And if cosine's negative, now sine divided by cosine, which would be tangent, would be negative. And if tangent's negative, then cotangent's negative. Flipping a fraction over doesn't change the sign. I'm only writing the negative ones now. To go left and down, your cosine has to be negative. So reciprocal, same thing. You're going down, so sine has to be negative. But if sine and cosine are both negative, a negative divided by a negative, which would be tangent, becomes positive. And if tangent's positive, his reciprocal's positive. Oh. Sorry, I guess I'll just write them all. I said I was only going to write the negative ones, but then I... Okay, and then finally the last of the long ways. If you think about the points in quadrant 4, you think about the unit circle points you memorize, all of the cosine values over here are positive. All the y values are negative, so all the sine values are negative. So his reciprocal is negative. And then tangent, that's sine divided by cosine, would be a negative divided by a positive, so that would be negative. And if tangent's negative, his reciprocal is negative. So, I guess it would have been harder, but I would have been fair to maybe put an easy version of this type of question on your last test. Because you know some of this stuff, so you have some idea. It just takes some thought. Honestly, I hate this. This is way too much work for me. We have a much nicer way that we don't have to dig so deep. Yes, you should know why these are all positive in quadrant 1 based on your unit circle knowledge. You should know why some of these become negative in quadrant 2, why some of them are negative in quadrant 3, why some of them are negative in quadrant 4. But the much quicker way is this acronym. So if you make this little chart here, this is a very, very common acronym for trig students to use. This tells you which trig functions are positive in each quadrant. So looking at quadrant 1, what's positive in quadrant 1? So the A stands for all. Everything's positive in quadrant 1. What was positive in quadrant 2? Sine and? Okay. And is reciprocal, so that's the S. The only ones positive in 3 were tangent and his reciprocal, which is why there's a T there. And then the last one, C, is a way to remind us that in quadrant 4, only cosine and his reciprocal. Oh, sorry, I forgot to say the acronym. So the most common acronym in order of the quadrants is all students take calculus. So if you do that, all students take calculus. I've got a quick little visual here that I'm in quadrant 1. All my trig functions should be positive. In quadrant 2, only sine and his reciprocal should be positive. All the others should be negative. In 3, only tangent and cotangent are positive. The rest are negative. And in 4, only cosine and his reciprocal are positive. The rest are negative. All students take calculus. 1, 2, 3, 4. You do have to know the quadrant numbers. If you forgot those, you need to add that to your notes. So we've got a few questions on here where it'll say something like, if sine's positive and cosine's negative, what quadrant would that have to be? So we're going to use this to help facilitate that so that we don't have to dig so much deeper like on the left. But while this is fresh, we can use this on the last couple questions to help us check some answers. In fact, for most of the rest of the first semester, this should be a good tool for you. Look at question 2. Our angle was in quadrant 4. And what this all students take calculus tells me is that in quadrant 4, the only trig functions that are supposed to be positive are cosine and his reciprocal. The other 4 better be negative or you did something wrong. So that doesn't tell you what you did wrong, but it does help you catch your mistakes pretty quickly. Likewise, in question 1, quadrant 3, all students take. So in quadrant 3, the only trig functions that are positive should be tangent and cotangent. So I look at my answers. Tangent and cotangent better be positive, and the other 4 better be negative. If you make a habit out of checking that, you will catch a bunch of your careless mistakes. So all students take calculus. You don't have to use this, even though you should be able to. This is really much more efficient. Just writing that at the top of your page for a visual. Okay, just like questions 1 and 2, sometimes you're given a picture and you're ready to go. Sometimes you're given a point and you need to plot it. And then we'll have some questions where you need to take a point that is on a linear line. So, in case you have forgotten how to graph linear functions, just a quick little reminder so that you don't miss any questions like that. If it's in mx plus b, b represents the y-intercept, m represents the slope, and so you can count rise over run to get a second point, and you only need 2 points to define a line. So you'll be asked to graph something like that and then take a point out of quadrant 2 or a point out of quadrant 4, and then as soon as you do that, it's like questions 1 and 2 on our notes. So once again, mx plus b, b is the y-intercept, which gives you a starting point. The slope is 1/3. You You can count rise over run to get a second point, and 2 points to find a line. So again, we're not really doing trig here. I'm just making sure you remember how to graph mx plus b. The way we will use this is we'll then pick a point in quadrant 1 or 3, and then work it just like question 1 and 2. We'll have a point to go with them. If your equation is not an mx plus b, you can solve for y so that it is an mx plus b, and then you should quickly be able to tell me the y-intercept, quickly be able to use the slope and rise over run. And we didn't used to do this on the notes, but I can tell you that people miss this on the quiz because they don't remember how to graph linear lines, but that is an expectation. Okay, not an mx plus b, so you could solve for y by subtracting 4x's from both sides, dividing both sides by 3, put the plus 0 if you need to see the plus 0. B is the y-intercept. The slope gets you another point. Count rise over run. 2 points to find a line. Okay, so again, I'm not throwing any trig at you on these questions yet. We'll see what you need to do from the book assignment. But is there any quick clarification questions about how to graph mx plus b, or if it's not in mx plus b? Okay, the rest of the back page is about knowing something called a reference triangle, which I've probably said a few times this year already. But we also ask you about something called a reference triangle here. So most of this is just kind of knowing how to set up the question. So a reference triangle, let's make 4 quick examples. All 4 possibilities. Either you could have a point in quadrant 1, your point on your terminal side could land in 2, 3, or 4. Lucas, you need to put your phone up, or I can take it. Okay, so a reference triangle, I kind of did this on the other page, but here's what the angles look like. Whether the angles in quadrant 1, 2, 3, or 4. The reference triangle is when you take this point and you draw perpendicular to the x-axis. Perpendicular to the x-axis. Sometimes you go down to the x-axis, sometimes you go up to the x-axis. These are reference triangles. The reason you need to know that in this section is there's something called reference angles, and the reference angle is this acute angle right here that's by the origin. So you need to know how to construct a reference triangle. Just draw the third side to the x-axis, and you need to know which angle we call the reference angle, the angle by the origin. The rest of the notes, we're going to talk about how to find the size of these reference angles. Okay, so the steps that you can follow is you can sketch the angle. Usually we call the angle theta. Then make your reference triangle, just like I did above. And that's going to create the reference angle, which we usually call theta prime. Theta is the big angle that starts at the positive x-axis. Theta prime is this small little angle made by the origin in the reference triangle. And then with some context clues, we can solve for how big that is. But a couple things you need to be aware of. If your reference triangle is drawn correctly, your reference angle should always be acute. It should be less than 90 degrees. If you get an answer bigger than 90 degrees or bigger than pi over 2 radians, then there's no chance that it's correct. And reference angles don't care about direction. They're really only about the size. So reference angle is always positive. So let's practice that on 4 of these, and then I will give you a second to try that on 4 as well. So I'm wanting to know how big is the reference angle to 110 degrees. So make a quick little picture. 110 is about here. It needs to be accurate enough to know that it lands in quadrant 2. This is what we call theta. That's the original angle. But if you take this point and draw it to the x-axis, you've created a reference triangle, and the reference angle that we want to know the size of is right there. So if this is 110 degrees, how much does this have to be? Okay. So let's think about why that works, because it's a little bit easier with degrees. What I would say on this question, and this doesn't work on every question, we have to use our context clues. All of this was 180, and the part of it that was not my reference angle was all of this, which is 110. So what was left behind would be the reference angle. So take a length you know, like 180 degrees, subtract off how much is not your reference angle, and it should leave behind how much is your reference angle. Reference angle has to be positive and it has to be acute, or it's going to be wrong. Okay, do the same thing for negative 285. I'll make my picture a little bit bigger this time. The bigger your picture is, the little bit easier it is to see. Negative 285 would land somewhere in quadrant 1. Because here's negative 90, negative 180, negative 270. That's about negative 285. Again, it doesn't have to be perfect. It has to be accurate enough that you land in the right quadrant. You don't land in the right quadrant, your context clues are going to be wrong. You need to sketch in your reference triangle. So draw to the x-axis to create a right triangle. And then this guy by the origin is the reference angle. That's what we want to know the size of. Now we can't just do the last question where we did 180 minus the angle given to us, because that just doesn't work here. Okay, well 285 plus 360 is not going to be acute, so I know that can't be my answer. You're on the right track, but you didn't quite say the right thing. There's not one right way to do this, but if we know this is 285 degrees and I ignore the direction, all the way around is 360. So how much did I not go around? I could take away this, and that leaves 75. That sounds right. Or you could say 90 was here, 90 was here, 90 was here. That's 270. So that must have been, this was another 15. And for this to be a right angle, this has to be 75. There's lots of ways that you can figure out that that reference angle is 75. But you've got to get your picture. You have to sketch in your reference triangle, which means you have to know what a reference triangle is, and you have to know which angle we're trying to ask for the size of. Okay, now to take that same concept to radians, we'll do 3 pi over 4. And our quiz will be no calculator, so you can't just convert this to degrees in a calculator, but I guess you could convert it in by hand. Also, this is an angle you should know from the unit circle, so either way. But 3 pi over 4 looks like this. That's the original angle. Take the point, draw to the x-axis, and you've got your reference triangle. And then this acute angle by the origin is the reference angle. So, any quick guesses on what you think that might be? Okay, well, if this is in radians, our answer needs to be in radians. Would you say 45 degrees?
That'd be 1/3 of pi over 3.
Close. Pi over 4. So again, if you can't see that easily, that's perfectly fine. But think about how we did question 4. We know this total distance is pi, taking a distance that I know. I can subtract away how much is not my reference angle, all of this stuff. And 1 pi minus 3 pi over 4 leaves what would be left over, the 1 pi over 4. Acute angle, it's less than pi over 2 radians, it's less than 90 degrees, and it's positive. If it's not positive and it's not acute, there's no chance it's your correct final answer. Okay, and then one more, and I'm going to have you try these other 4 in 2 different sets of guided practice. So, negative 7 pi over 6 would be about here. Which means this is my reference triangle. Here's my reference angle. If I remember correctly, the textbook, well, I have it out in front of me. The textbook asks you to sketch these, and then I think on our quiz we don't make you sketch them, but you guys can see that if you're not sketching this, it's really hard to compare, and without a sketch, these questions are just really hard. Maybe you could do the first one, but okay, so we've got to be able to figure out how big that is. Just this little piece here. So somebody, I'm guessing, is going to think that the answer is negative pi over 6. How do you know that that's not correct without actually working it out and getting the answer? Right, reference angle has to be acute and positive. It does not care about direction, so that can't be the answer. What I would say in this question is this turn was 7 pi over 6. I don't care that what direction it was in, so I'm just thinking about how much of a turn it was. And then if I come back and subtract how much of a turn it was that is not part of my reference angle, again, I don't really care that it's in the negative direction, just how much do I need to subtract? Then what would be left over is the reference angle. So 7 pi over 6 minus 1 pi over 6, or 6 pi over 6 would be 1 pi over 6. This is 6 pi over 6. This has to be 1 pi over 6 to get to 7 pi over 6. So, lot easier with the picture, but you got to practice to make sure that your picture is set up correctly so that you can use it correctly. Okay, so before we slide over to the book assignment, if you would try 8 and 9, try the 2 that are in degrees, make the picture and come up with a size for your reference angle. Again, there's not one formulaic way to say always do 180 minus the angle given to you, or do pi minus the angle given to you. You have to just use context clues about what it's near and around. Just one more minute. You'll get to practice several of these out of the book, so I apologize if I'm going to rush you on, but okay, so 215 is a little bit more than 180, so somewhere in quadrant 3, and negative 75 would be in quadrant 4. So here's your two reference triangles, and if you know this is 215, that should be enough of a hint to help you find the reference angle. So I'm getting 35. Everybody got that? Okay, the whole turn, this whole angle was 215, and the amount of it that is not the reference angle is 180. Subtract those, and then what's left over would be what you want. Okay, this is supposed to be negative 75. Well, isn't that just a reference angle? So my answer should be negative 75 degrees. Why not? Can't be a negative. But if I'm turning 75 degrees, then that reference angle is 75 degrees. You didn't have to do any real arithmetic for number 9. If I turn this much down, negative 75 degrees, it is its reference angle. Alright, and of course degrees are just a little bit easier to catch on to because we're a little bit more familiar with them, but you also need to be able to do it in radians. So try to plot those two, make your reference triangle, and see if you can come up with the reference angle. Yep. Just be careful when the way you wrote it. Like, this is fine that you're doing that to help you, but if the question's given to you in radians, make sure your answers in radians.
I just did it to check to make sure.
Yeah, that's good. Okay, once again, just one more minute, and I apologize if that's not enough time, but Okay, so 7 pi over 4. Again, there's lots of ways for you to find that, but I know where 1 pi over 4 is. Count it 2, 3, 4, 5, 6, 7 times. And again, for our purposes, as long as you land in the right quadrant, that's going to be accurate enough. So that's what your reference triangle should look like. Over here, negative 7 pi thirds. Well, this is how much 1 pi third is, 60 degrees. So here's negative 1 pi thirds, negative 2, 3, 4, 5, 6, which makes sense. 2 pi is all the way around. Negative 7 pi thirds. So both of these landed in quadrant 4. Always draw your line to the x-axis to make your reference triangle, never to the y-axis. And then this is the angle we are interested in knowing the size to. So in number 10, I would say that my reference angle would be what?
45 degrees.
Okay, if this is in radians, we need to make sure this is in radians. So 45 degrees in radians is
Pi over 4.
pi over 4. So if you didn't get that, I would say one thing you could have seen is that all the way around is 2 pi. That's one that we know. And then if I subtract off this much that is not the reference angle, which I happen to know that much was exactly 7 pi over 4, get your common denominator. It's like 8 pi over 4 minus 7 pi over 4 leaves you behind 1 pi over 4. Okay with that one? Okay. Over here, well, I don't know. I went all the way around, and then I went one more pi over 3 down. So if after I went all the way around, if I went down pi over 3, then that means this distance is pi over 3. And so I guess that's all you have to do. The other thing you could do is you could say I went all the way around plus this much. So if 7 pi over 3 is how much I turned, and the amount of that turn that's not the reference angle is exactly 1 full rotation, which we know is 2 pi, or 6 pi over 3, then that last little piece here needs to be pi over 3. But to help you catch yourself from silly arithmetic mistakes, make sure your answers are always positive and make sure that your answers are acute. If either one of those are not true, then there's no chance that your answer is correct. Okay, any quick questions there? Again, you'll get to practice it more out of the textbook, but if you have a question now, there's no sense in waiting.
I put it in the wrong quadrant, but I still got the same answer.
You just got lucky then, so sometimes that'll happen. Okay, then your blank piece of paper that you guys got out, if you go ahead and copy down the full assignment, and I give you just a second to do that, and then I'll discuss some of it with you, and then ask you to work for a few minutes before I take questions, and then work for a few more minutes before I take more questions, and then try to help you guys get as far through this as you can so that you have less homework. you guys would, go ahead and finish copying that down and then dive into the first 2 questions. There are the 8 vocab questions, so answer those first, please, so you don't forget about them. And then it looks like after that, the next 1, 2, 3... The next 3 questions are like the first 2 that we did on our notes. So what I'm going to do today is give you guys about a 10-minute head start. And then once our 10-minute timer's up, I will let you ask a couple questions if you have any. And if you don't have any, you can keep going. And then we'll just rinse and repeat as much as we can. And again, I still will take questions next class. You will always be able to get a chance to ask questions. Yep, looks good. As always, as you guys get stuck, just do what you can and then be ready to ask that question. But just one more minute and then I will help with a few. Okay, so I know that wasn't a lot of time, but hopefully enough time for you to get a few questions under your belt. Any of the vocab check you couldn't find, or 9B, or I think the next one was 11A. That's probably all you had time to get to. Any of those you'd like me to discuss with you?
7.
Okay. Number 7 says because r, the radius, is equal to the square root of x squared plus y squared cannot be 0. The sine and cosine functions, I would say, probably exist is probably the word they're looking for. Defined. The sine and cosines are defined for any real number. Again, don't forget, vocab check is always exactly word for word in the page or two before it. So I also didn't know the exact wording they were looking for there. But when we ask you for what functions are undefined, sine and cosine are never undefined. Go around the unit circle, they always have a value. Yep. Okay, if you needed help with 11A, then I will go over that on the board. If not, go ahead and just use that time to work a different question. Okay, this one gave us a point in quadrant 3. At negative square root of 3, negative 1. So I guess what's a little bit harder about this one than 9B is the square root means you're probably going to have to rationalize. Okay, but to see your reference triangle, you should draw this to the x-axis. And then to get to this point, I had to go left square root of 3 and down 1. That's how you get 2 of your 3 sides. Yeah. Y times 1. Plus 1. So it looks like the hypotenuse should come out to be 2. Now, I wouldn't say this was a common problem, but I did see some Pythagorean theorem mistakes on our test. Again, you guys are welcome to come see your test as soon as they're made up during advisory sometime. So that'd probably be the end of next week would be the earliest. But just be careful with that, just because you guys have seen Pythagorean theorem for a long time. You do make mistakes sometimes. In fact, I did earlier this morning. Okay, you have to know which angle you're looking from. We're looking from the reference angle. And I'm assuming it wants all 6. As the semester goes along, we don't usually ask for all 6. But at first, you need to make sure that you can find any of them that you may need. So, sine would be opposite over hypotenuse. The negative 1 is across from, so that's opposite. Hypotenuse is, of course, opposite the right angle. I can flip that guy over pretty easily. Cosine would be adjacent over hypotenuse. and we can flip that over, but that one needs to be rationalized. Multiply the top and the bottom by the square root of 3 before you get your answer. And tangent needs to be opposite over adjacent. Rationalize. Cotangent, you can flip this over. And rationalize. Now those are some pretty familiar ratios. So this is probably an angle on the unit circle, but it's not asking us to determine what the angle is, just be able to work with those pieces. So again, the part that you should feel fairly comfortable with was how I got sine, cosine, and tangent with SOHCAHTOA, how I got cosecant, secant, and cotangent from sine, cosine, and tangent. What should be new to you is plotting this point. Well, actually, you didn't even have to plot it because they did it for you. But making a reference triangle and using this point to identify 2 of your 3 sides. Everything after that should just be extra practice from what we've already done. Okay, I think the next one after that was like 13, 15. So 15 and 19. Actually, never mind, just 15. 15 is the exact same thing, they just didn't make a picture for you, but they just gave you the point. So that's all you really need. So let me reset our timer, give you another 10 minutes to get a few more questions under your belt. If you get completely stuck, skip it and be ready to ask. Otherwise, get as much done as you can. post-it notes. You're flipping back and forth to check your answers. You just put the post-it note back on the solution page so that you don't have to try to hold it the whole time. Make them hold it in here. Or you can take a picture of the solutions with your phone and then have your phone. That's going to be the all students take calculus type of question. So try it, see where you get stuck, and then just be ready to ask. I'm going to take more questions in about 3 minutes. Did anybody else want a post-it note to bookmark the solutions on the back? Okay. If y'all change your mind, you're welcome to more. And even those of you that did them, you may not get the same book next class, so I've got plenty. Just ask for them in the future as you need them.
Is this bookwork due next class?
You need to try all of it before next class. Because next class you have the first half of class to ask questions and get clarification on what you couldn't figure out, and hopefully a few minutes to study.
When you rationalize like with the negative square root on the bottom, do you like would it be like negative 29 on the bottom?
When you say a negative square root like this,
Yeah.
okay.
When you rationalize it with the 3 on the bottom, also negative or just positive?
So when you rationalize, it doesn't. I'm not sure what your question is, but you have to multiply the top and the bottom by the square root of 3. Are you asking, can you multiply by the negative 2?
No, I'm just like, is it negative on the bottom when you rationalize
Oh, it's
it? Like,
either-
does it keep the negative sign?
Yes, it doesn't go away. Yes, and in a fraction, whether your numerator is negative, your denominator is negative, or you have a negative out front, all of these mean the same thing. So, but yeah, your negative won't just disappear. Okay, that has been another 10 minutes. So now that you've had time to try a few more, what other ones can I help with?
25.
We're at 25. Okay, if you have not made it to question 25, it is your choice. You can either follow along with us here, or you might have to watch the class video later. Okay, find the exact value of the remaining trig functions. So they already gave me sine, so I still need cosecant, cosine, secant, tangent, cotangent. I like to start with blanks for my answer so I remember what I need to get. the angle is supposed to be in quadrant 2 and sine is 0.6. Well, the first thing that bothers me is I don't like to look at this as a decimal, so change this to a fraction. This is the same as 6 over 10 or 3 over 5. I know my triangle is supposed to be in quadrant 2, so I can sketch a triangle in quadrant 2. And then if sine is 3/5, sine is opposite over hypotenuse. So I can give you cosecant now. But for the other 4, I'm going to need to know the adjacent side. Now, if you didn't get the question 25 yet, you need to make sure you're paying attention to this part, because this is key. First off, some of you can take a shortcut and say that this is a 5 triangle? Did you say 4? Okay. 3, 4, 5 triangle. That's not 100% correct. And if you do Pythagorean theorem, you're going to get something that looks like this. You're going to get A is 4. But this length is not 4. Why is it not 4? Because it's going to the left. Pythagorean triples have no idea if you're trying to go left or down. Pythagorean theorem is great at finding lengths, but it has no idea if you're trying to go left or down. That has to be a -4. And if you're not paying attention to your picture and you're just using your Pythagorean triple or using your Pythagorean identity, Pythagorean theorem to find that, then you're going to miss it. That's a 4. But assuming you get that, you can get this, and SOHCAHTOA again for this. And the way that you could maybe catch this mistake, what I told to you guys in your notes earlier, is use that all students take calculus acronym. If your angle's in quadrant 2, the only answers that better be positive are sine, which was given to me, and his reciprocal. If those are the only 2 positive trig functions in quadrant 2, your other 4 answers better be negative. And if you put that thought into it, if you forgot to make this 4 negative, you aren't paying attention to the directions, then you will at least have an opportunity to catch that mistake. Think about what quadrant your angle's in to know which trig function should be positive or negative, and that will help you catch some of that stuff. Okay, was that enough for 25? Okay. Is anybody else going to ask about 25? Need something more out of that? Okay, somebody else? Yes.
31.
31. Okay, so cotangent's undefined, and my angle is bigger than pi over 2, but less than 3 pi over 2. Well, this is just a real fancy way to say that it's somewhere in quadrant 2 or 3. The angle's bigger than pi over 2, but less than 3 pi over 2. So it's somewhere over here. And then my other clue is that cotangent's undefined. Well, cotangent's the same thing as cosine over sine. So what would have to be true about sine for this whole thing to be undefined? 0, because dividing by 0 is how you get undefined stuff. And then where within these angles is sine going to be 0? Pi. So you've got to do all that work to find the location, but since that's a unit circle spot, we know the point, and we don't even have to do SOHCAHTOA now. Cosine's the x value, sine's the y value, tangent is sine divided by cosine, flip cosine for secant, try to flip sine to get cosecant, and try to flip tangent to get cotangent, but that one should just match up with what you got. So a little bit more discovery to try to find the location. But this is telling you where to be looking. And then think of cotangent as cosine over sine, and something's undefined when you try to divide by 0, so that's when sine is 0. So that helps you find the spot, and then once you know the spot, unit circle point gives you all the trig values. But that one's a little harder. Okay, somebody else have another question or two ready to go? Yes, sir. 33? Okay. Alright, to me this is very similar to question 9b. So if you can do 9b, you can probably do this question, but there's one extra hurdle to get started. You need to take a point on this line that's in this quadrant. So the first thing you need to do is you need to sketch what this line looks like. This is why we practice this on the notes. He has a y-intercept of 0 and a slope of -1. So go down 1, right 1. 2 points determine the line. So he goes to the point 1, -1, but this is in quadrant 4. It said take a point out of quadrant 2. So if I backtrack, there's also a point at -1, 1. And now this is where it's the same as 9b. If you've got a point, it's like you know 2 lengths of your right triangle. You can do Pythagorean theorem to figure out that the hypotenuse is square root of 2. And then whatever trig functions you need, this one wants all of them. We can get with SOHCAHTOA. But the key, what's unique about that question is they don't just come out and say, hey, here's the point, like they did in question 15 and 9b and 11a. You had to do a little bit of work to find a point. So any point in quadrant 2 that's on this line, make sure you graph the line correctly and make sure you take the point from the correct quadrant. You take a point from quadrant 4, it can't be correct. And then just to practice what I preach here, since I wanted something out of quadrant 2, again, 5 seconds of work. All students take calculus in quadrant 2. The only answers that I have that better be positive are sine and its reciprocal. Sine's positive, his reciprocal is positive. The rest of my answers have to be negative. So if that was not true, something was wrong. Now, the neat thing about this question, and I'm not going to spend a long time on this, but I took the very first point that I found in quadrant 2. You or your neighbor may go further in the quadrant 2 and do this point. You're going to end up with the exact same trig values because all of this stuff is proportional. Your numbers are going to look a little bit bigger, but when you reduce all your fractions, you're going to end up with the exact same answers. Okay, is that enough on 33? Anybody else that's going to ask about 33 have something more specific? Okay, 34, 35, and 36 are the same type of questions, so I'd like you to attempt those before you ask for help on those. But is there any others ready to go before I set one more timer? Okay, I can't set a full 10-minute timer, but let me give you a few more minutes to hopefully find 1 or 2 more things I can help with. And then I'll remind you what your homework is and what plan is for next class. hate to cut you off so quickly, but in order to help you with another question or two, I need to take that. Otherwise, we will run out of time. So, another one, 34. Let's wait on that one, since I just did 33 and it was the same type. So,
19.
19. Okay, this is a good one to ask. If sine is positive, but cosine is positive, determine what quadrant this happens in. So I'm thinking of the all students take calculus. All students take calculus. So in quadrant 1, they're all positive, like sine and cosine. In quadrant 2, sine and his reciprocal are positive, but everywhere else he's negative. So, based on this clue, your answer has to be quadrant 1 or 2. Based on this clue, for cosine to be positive, they're all positive in 1, and cosine and his reciprocal are positive in 4. So that means he's negative everywhere else. So from this clue, if it has to be first or second quadrant, and then from this clue it has to be first or fourth, the only quadrant that both of these things are positive in is the first quadrant. So one answer. Again, you can think of that from the unit circle approach, but it's a lot more time consuming than all students take calculus. So. All right, so what I need y'all to do, I believe this is a B week, or I'm sorry, an A week. Let me double check. Yeah, it looks to be an A week. So on Friday, when you guys come in, you need to have completed this assignment. Use the videos on the website as much as you can. The first 45 minutes of class, I'll let you ask questions, let you look over your notes and study, and then the second 45 minutes, we will take the quiz over 4.4, and they're all questions just like out of the book. So. Yeah, so
We gave you.
1/3, so that's the same as going backwards. I don't know, I can't do it that fast in my head.
Because that's what it looks like. It's going positive, so just flipping it.
So, okay, I'm with you there.
So,
And then
that's
hypotenuse is
correct.
always positive. That looks correct. Yes, I think you got it set up right.